Okay, thanks for coming, everyone. My name is Mo Morrissey. I'm a software engineer at Red Hat. I've been working there for a few years now. I'm here to talk to you about a project that we're working on called Aeolus. It is an open source cloud computing API. So, before I jump into the actual project, let's talk about cloud computing for a second. It's a very misused term. It's a very new field. It's tied to a lot of products by marketing, by sales, and whatnot. And unfortunately, that creates a lot of confusion. But it is rigorously defined. The NISC has a definition out there. There are various working groups in the industry that are working to define the standards behind the cloud, behind cloud interfaces, and so on and so forth. The field of cloud computing is a new field. It's an extension upon existing concepts, extension upon virtualization, extension upon the concept of viewing resources as an opaque cloud. But it's kind of a new binding, a new unification of these existing technologies into services that really bring a very powerful computational resource to the end user. Is it the be-all, end-all? Absolutely not. Like anything else, you need to know the problem at hand and the options which are available to you in order to best leverage those resources for your own benefit. So this level of cloud computing that we're talking about is infrastructure. Infrastructure as a service. You often see the acronym as a service. PaaS is platform as a service, where you have tools that are coupled to your specific platform that you're deploying to. Well, infrastructure as a service is the situation where you're given cloud resources such as virtualized instances, which may be associated with CPUs, memory that's available to you, perhaps some storage resources, and so on and so forth, so that you can leverage that to set up your own stack and go on from there. So when we talk about cloud, that's what we're talking about here. So, what's the problem at hand? We're seeing a lot of the same issues in the cloud computing industry that we've seen in the past. Proprietary APIs, proprietary data formats. These things have occurred. You know what happens. Why are we repeating the same mistakes of the past? Currently today, Amazon EC2, Amazon Web Services, that is the #1 cloud provider of infrastructure. But a lot of their delivery mechanisms and mechanisms to leverage their APIs are very coupled to implementations. Even open source cloud implementations, things like OpenStack, CloudStack, Over, Eucalyptus, and name it. The cloud is a very complicated thing. You're orchestrating a lot of different components, which in themselves they may be moving, they may be shifting. So, if by adopting a specific cloud implementation, you're kind of tying yourself to that implementation. You're kind of limiting the choice and the freedom that you have down the road. Now you've invested all these resources to adopt in one specific type of cloud provider that you are now all of a sudden, your images are based on that cloud provider's format, your scripts to orchestrate your configuration and your deployments are based on that format. So now you have a kind of a stake in this particular way of doing things. Now, if that way changes or the community goes a different way, well, now you're kind of stuck. You're between a rock and a hard place. So we're proposing a framework, a set of tools that lower the cost of deploying to the cloud in terms of man hours, in terms of cost and pricing, and so on and so forth. Aeolus is an umbrella project. Aeolus is the Greek god of the winds, cloud computing. And it's essentially a suite of tools that you can use each individually. You can use them together in an orchestrated manner in order to free yourself from a specific cloud implementation. And I'm going to show how to do that right now. So I have a demo set up. I brought my cloud in a box, as they call it. External resources being what they are at conferences, I kind of wanted to bring in a cloud that is conceptually external from my Aeolus control station. Aeolus is like I said, a suite of utilities. Almost all provide RESTful APIs, which you can use in a local manner, like libvirt, to control local resources or to control remote resources, or you can set it up in a data center, which to control a cloud from a centralized point, proxying lots of user connections, and so on and so forth. So I'm going to show off the first component of the Aeolus suite, which is called Delta Cloud. Now I have Aeolus running on a VM on my laptop here, so I'm going to SSH into that. Password. Actually, a bunch of settings. Session. Now, Delta Cloud provides a RESTful interface, like I said, and it provides wrappers to the interface for C, for Ruby, for Java, what name you. So I'm starting up an instance of Delta Cloud. I'm specifying an endpoint which to connect to. Delta Cloud can serve multiple providers. You can specify in the REST headers, the HTTP headers, which provider you're connecting to, the credentials, and so on and so forth. But for this example, I'm just showing Delta Cloud being run against one provider. This is the default provider. If I can override that with each request. Delta Cloud is stateless, so it scales very nicely. But that means also that each request needs to specify the connection parameters and so on and so forth. If there are any questions or anything at any point, feel free to stop me. Else I'm just going to continue. Now here I popped open a Ruby terminal. I'm just going to be using the Ruby client because I'm more comfortable with the Ruby development environment. I'm a Ruby developer, so I'm going to first connect to Delta Cloud. Then I can do things like list instances, and this is a bit of Rubyism so you get to learn a little Ruby today as well. So I'm iterating all the instances. I'm just going to print out the ID and name. And it takes a second to connect to the cloud provider. I can do the same for images. I can launch an instance. Specify the image I need to base it off of. See that additional instance right here. Oh no, what's this? That was in the previous list. Grab a handle for that. It's running. See different actions I can invoke on it. I can SSH over to my OpenStack. SSH is wraps the normal commands to all these instances. And so you can see this instance right here. I can use the same API to connect to Over being the upstream version of Red Hat's cloud service. Specify different cloud provider endpoint. Connect to it using the web credentials. These are fake passwords, by the way. Or passwords, I say, please don't. And then the same thing. And so on and so forth. So, it's a very easy API to use. It works. It's communicating with the different cloud providers. It's simple. You use it, like I said, in RESTful manner. It's very well documented. The Delta Cloud guys are a very, very smart team of contributors. They're working, as like I mentioned before, with different groups across the industry. For example, one of the lead developers, he's working on the Distributed Management Task Force. It's a working group that's building or drafting what's known as CME, the Cloud Infrastructure Management Interface Standard. And this is just an open standard that a lot of groups and organizations and communities across the industry are agreeing to, how to control cloud infrastructure and so on and so forth. Delta Cloud is how you do that. Delta Cloud is, the very simple abstract API that you can use to, if I go in here, the over instance, for example, I just started isn't running, so I can, by default, over will create instances in the stop state, so I can list the actions and view the instances and then start from there. So Delta Cloud provides a mechanism to advertise resources and advertise capabilities of those resources and collections on those resources in a very RESTful manner that you can consume and very easily control many different cloud providers.
When you say different cloud providers, are you providing pre-provided?
Well, like I said, Delta Cloud is stateless. So here in the server where I'm launching it, I specified the API provider. This is the default API provider of endpoint. I have over Aeolus in my local host file to this machine. And if I don't specify any endpoint, it'll just use that. And then I can override that in my every REST request I send. It's just a header. And then in every request I send the credentials, yes. So, it's stateless. It doesn't store anything in the local database because, once you start getting into stateful things, it's really hard to scale and, performance we're looking for and so forth. The nature of the cloud is a very web service oriented entity. For better or for worse, most cloud APIs offer their services over REST. So, in the same manner, you can consume Delta Cloud and leverage those APIs in an abstract manner, right from, like I said, I just showed Ruby, but there's a command line client that you can install separately, and so on and so forth. So, it's a really cool, really well designed tool that I encourage everyone to check out. It can be installed separately. It can be installed with the rest of the Aeolus suite. Feel free. It's in Fedora right now. I don't know what the current state of it in Debian is. There might be debs, but it might not have been submitted, to Ubuntu and whatnot. So, it's a very active, vibrant community. If anyone is interested in this type of thing, feel free to join us. We have kind of a shared IRC channel, Pound Aeolus on Freenode. Aeolus on list.fedora hosted is our mailing list, and aeolusproject.org is our website. So, you go to the website and everything's there. So, if anyone's familiar with cloud services, they know that they're often broken down into computational services and storage services. Cloud providers often offer, an API which to access the instances and the hardware profiles and so on and so forth that that are available on that cloud provider, and they often offer a different API which should access things like S3, things like blob-based storage services, and so on and so forth, key value pairs. So our analogous to the storage API is Image Factory, which is a command line tool, and it also provides a RESTful interface and a Qpid-based interface, or a AMQP-based interface, I should say. So you can use it as a centralized point, just like Delta Cloud. With Image Factory, you create what are known as TDLs, or essentially just high-level templates which describe the type of image you're trying to build. So this is the type of thing that contains the instance that you're going to be running in the cloud, the repositories, the packages to install the files, and so on and so forth. And Image Factory goes and uses a tool behind the scene, one of our most popular tools called Oz. Oz is a component that the end user doesn't actually interact with when they're interacting through the suite through Image Factory, but Oz, nevertheless, is a very popular tool which is used to bootstrap an instance on the cloud using the tooling native to that instance. So what this means is that we can generate very, very lightweight base images for the cloud that are as portable, that are as small as possible, and then from there, those instances have the capacity to bootstrap their own services, their own configurations using the local apt-get system, the local yum system, the local Windows tools, et cetera, et cetera. So it's a really nifty tool. It's very small, very targeted, very purposed, and you can use this to bootstrap instances on VMs, instances wherever else. You can use this to bootstrap your configuration system. I'm going to talk about our configuration component in a bit, but no matter our configuration component works with across the board with Puppet, Juju, whatever else that you want to configure your services. But it's kind of a way to bootstrap all that and so on and so forth. So one of our central goals, let me step back for a second, of this project is to be compatible with with essentially everyone, at least as many different solutions as possible. Because like I said, the cloud is a very new thing, a very dynamic thing, it's moving. So we don't want to box anyone. We want to be able to, almost all our APIs are very pluggable, very modular, so that they're very easily to extend. For example, Image Factory, you can define additional plugins for additional cloud projects extremely easily, and different types of hosts on those cloud providers, and so on and so forth. No worries. Unless you need distraction. All right. So, I was kind of debating whether to should actually show off Image Factory. The only problem, I would like to show importing the template and so on and so forth. It is somewhat a resource-intensive operation, building images and so on and so forth. So I think I'll just skip over this for now, but we can move back around, or we can talk about it later on as well. Another component that I mentioned before is Audrey, which is our config server, and that is what works with Juju, with Puppet, and so on and so forth, to kind of bootstrap your configuration system in the cloud. It's very seamless. It leaves high to all these tools. And I actually have a very short video to show off on Audrey in action. So, play it.
Audrey will facilitate. This demo will use Audrey to launch an application across a multi-instance deployment. We'll use WordPress as an example application. The first instance will be an Apache server, and the second instance will be a MySQL server. At launch time, the instances will need to know about one another to be configured. Audrey will facilitate passing this information between the instances. In addition, we'll also use Audrey to sequence the configuration and startup of services across the nodes. That way the application will not try to connect to the database before it's ready. The image being launched was built including Apache, WordPress, MySQL, and the Audrey agent. I'm going to first launch the deployment in Conductor, then explain what's happening while the instances are...
Conductors are a web UI that sits on top of them. We'll get into that in a second. The interface you're going to see is a little bit older.
coming out and being configured. Here's the two assemblies, Apache and MySQL. There's 3 parameters here. They all have predefined values. There's 3 reference parameters for Apache. MySQL looks very similar. This is the deployable. There's 2 assemblies, Apache and MySQL. Each assembly has an executable defined in it. The executable will not be invoked by the agent until all the parameters have been collected and given to the agent on the instance. The Apache instance needs 3 parameters which we've given values to and has 3 references to the MySQL assembly. Apache returns hostname and IP address. MySQL has the same 3 parameters for the database name, user, and password, and references Apache's IP address and hostname. MySQL returns hostname, IP address, and dbup. Dbup is a parameter that will be defined at the end of execution of this script. This is the dbup fact that will be put in place so that when the agent calls factor, factor returns true for the dbup fact. Because Apache depends on the MySQL dbup fact, Apache's instance will not execute this script until after the dbup parameter has been given to it. The dbup parameter will not be given to it until after MySQL has executed this script. Therefore, MySQL will be up and running and ready to receive connections by the time the Apache script is invoked. This is the script for MySQL. It simply starts MySQL, creates the database, grants permissions to it, sets a password for the user, and then puts the dbup fact in place for factor. This is the Apache script. It edits the WP config file, starts Apache, and then invokes the installation script for WordPress. You can see we're using static admin username and password here. That can be customized using Audrey as well. This is the dbup script. Before it's put in place, fact dbup returns nothing. Once it's put in place, it returns true. You'll notice that the Apache script doesn't reference dbup. It's only being used as a dependency, so that the script on the Apache instance isn't executed until that fact exists and returns a value. Let's check WordPress now. WordPress is installed and configured. And we can log in with the static username and password that was configured. What you've seen here is the use of Audrey to do 2 things when launching an application across a multi-instance deployment. 1, launching 2 instances that need to know about each other at launch time and their information being passed through Audrey for configuration. Second, the sequence of configuration order of the 2 hosts so the application host doesn't try to connect to the database before it's ready.
So it's a very powerful tool. You can use it to configure multi-cloud deployments. Like I talked about, I mentioned a minute ago, and as you saw in the video, the UI that unifies everything is known as Conductor. And this is the Conductor web interface. You can install this easily by installing the Aeolus all package, and there's a script that is part of that Aeolus configure that will set everything up for you. That sets up the entire suite. Aeolus, Delta Cloud, Image Factory, the various components which are needed to kind of glue and bind everything together, this being kind of the more prominent one. Now this is the web interface in which you describe very high-level entities, things like pools, which are groups of cloud providers, things like which users and the notion of users and permissions and roles which can be assigned to those, and providers with their accounts, so that the end user doesn't have to have specific access to these cloud providers. Here I'm logging in as the admin, but they can deploy to pools which the providers are in. The Conductor also environments are contains notions of many other things, such as environments, which are collections of configuration and catalog of different config profiles, which can be used through the configuration system to be applied to your different deployments and your different cloud provider instances. Different cloud providers can advertise things like realms, which you can create on the Aeolus front end and then tie different realms together so that you can kind of have a little bit more flexibility in terms of organizing your instances. You don't have to necessarily limit yourself to the geographic or the categorization which the cloud provider specifies. It also provides hardware profiles, which I mentioned before. HWPs are collections of resources that the cloud providers advertise. And then those collections are, you can create another one on the Conductor front end, or I also should mention Conductor provides a complete REST API. Everything that you can do via the web interface, you can do via the command line client. I'll show that in a second. So these hardware profiles, the cloud providers themselves advertise them, and then you can create ones of your own that you say, hey, my instance needs, my deployment needs these hardware profiles, or the hardware profile matching this configuration, and then the cloud provider will say, okay, one of these cloud providers in my pool that I have access to has this configuration, and then you can deploy to those according to many different settings. For example, if I jump into a environment, you can say strict order, penalty failure, et cetera. There's additional ones, pluggable, and so on and so forth, so that you can have different strategies when controlling the cloud. Like I mentioned, there is a command line client, just very simply Aeolus, and then you can do things. So, just really easy stuff, very easy, high-level API, which to kind of control the cloud, control different resources, associate things in accordance to how you want to associate it, how you want to use different cloud resources, and how you want to leverage those.
Who are you considering a cloud provider, like Amazon or what?
We have, Amazon is one of our biggest use cases. For example, if I go to the Delta Cloud website, you see a list of providers that we support through computational, through our storage APIs. It's we're very open to contributors. Different cloud providers have come to us and they say, hey, we want to work with you guys, we want to be compatible. Different end users who are looking to work with different cloud providers. I'm one of the developers on the project, so if at any point, we have a team across the world, feel free to ping anyone in IRC for whatever reason you don't get a response, ping me. I'm Morsi. I'm always in Aeolus. I'll be willing to help you, willing to find out what you need, how you want to deploy to the cloud, and so on and so forth. We can develop solutions together. We're starting to look at, we've defined some of these templates to deploy instances of the Fedora infrastructure to the cloud, and so on and so forth. We're just looking at different communities, different ways to get involved in helping people deploy their own infrastructure in a manner that's free and that's open.
Question, is OpenStack considered a cloud provider, or is that a cloud something else? Like HP has OpenStack, so would you, if you're compatible with OpenStack, would you be compatible with HP's cloud?
Yes.
Okay.
It's a great cloud provider. It's like I said, the cloud. It's kind of a funny story. When I was setting up this demo, the hardest part, in my opinion, was setting up the cloud providers. Granted, I am familiar with Aeolus, but Aeolus was pretty simple. Clouds are very complicated things. They involve orchestrating a lot of components. So, even though OpenStack's a great piece of software, it was relatively hard to set up. And as were some of the other ones I tried. So, this just kind of goes to show that it's a very new field, and there's just a lot of things that are dynamic. As different organizations look to start up OpenStack instances or leverage public resources, it might not be a bad idea to look into something like this to be able to, okay, if I'm starting up a couple scripts, fine. You know, it's easy to use the tool is supposed to be a cloud. Well, all right, well, hey, I showed it worked, great. Okay, you know, we'll start adopting these cloud resources. All right, well, I'll start automating my job. You know, start writing some scripts around this. Okay, well, you know, I start using some of the configuration, some of the cross-cloud resources to, you know, orchestrate these things. Now, all of a sudden, I'm tying all these. Let me step back. Not the cross-cloud resources, but I'm using services to orchestrate my deployments to the cloud. Well, now I have all these components which are tied to this specific cloud provider. You know, they went from, hey, I just use, you know, a few commands to, we all know how quickly these problems balloon. So this you know, really goes to show that through this simple API, through simple interface, you can create scripts that you can easily configure parameters, change your cloud provider, easily configure, you know, you have a template that you can deploy to any cloud provider. So through just changing a couple of commands you use, you can really leverage a lot of different resources. And that kind of brings me back to the presentation. You know, I wanted to loop back around about, you know, this concept of choice. We're here because we love open technologies, we love open APIs, we love open formats. We've seen the same trends that we're seeing in the cloud industry. Why are we repeating the mistakes of the past? You know, by adopting these solutions, as convenient as they may be, we're really setting ourselves up for a situation in which we're just causing so much more headache. I mean, let's look at the problems that we're dealing with today because of all the proprietary formats and the proprietary APIs we chose. So, you know, let's avoid that before it becomes a problem. Let's choose open technologies, open formats, that we are free, that we are, you know, able to pick and choose what we want. We are able to adapt the solutions to our needs instead of now having to come up with additional solutions to problems which did not exist before.
So on that topic then, if I had a large infrastructure on EC2 and I have tons of scripts, like does Aeolus have an easy way for
A compatibility layer? We are building a compatibility layer. I mean, it's one of those things that we kind of don't want to advertise too much because, like, now all of a sudden you can use the Aeolus services with EC2 compatibility, you know, so it's like people start developing next EC2's API still and so on and so forth. So, I mean, it's one of those things that, yeah, we are building, you know, to support, but, you know, we want to encourage people to use open APIs as much as they can. It's kind of...
Even if there was a conversion.
Right. I'll get to you in just 1 second, sorry. It's kind of funny, I mean, like I mentioned, Aeolus is a suite of tools. One of the tools that I was working on called Snap is a system snapshotter, which, just like Oz, it uses the tooling native to your instance to take a snapshot of the instance. So it'll take a snapshot of, you know, packages you've installed using the package system, services, and so on and so forth, and then you can restore that in a different cloud provider. You can export that to a TDL, which you can use to base images off of different cloud providers. So it, you know, assists with that migration and so on and so forth. So, you know, that's a little bit different. That's kind of an in-cloud instance as opposed to the API, but it's along the same lines. So, question?
Comment on his question. I was at a different talk, Collabo Great, and that person talked about basically taking scripts and kind of, I think he has an answer for your question. I think a solution for your question. He might be able to provide a way to do that. It's online. It's Collabo Great. It's the 2 p.m. or 1 p.m. on the track 1 on the thing. I think it might be a way, and I think that some of the ideas that he has might work really well with some of the things that you have. You guys need to talk.
Okay, yeah, sure. I'll check it out. Thanks. Okay.
So if all those sort of cloud providers that you listed are on board with this Aeolus thing, then who's doing the lobbying and who's not on board?
Well, they're not necessarily on board. I mean, we have support for them. I mean, Amazon EC2 didn't exactly come to us and say, hey, you know, we want to be part of this. You know, they might have, but so we built like Amazon. Like, you know, we've had the Fujitsu cloud provider. They're the ones who implemented that, their driver. So, you know, it's kind of a mix. If there's, you know, we receive requests too, that, you know, and they're really easy to write. So, you know, if someone went to a conference like this one, talks like, hey, you know, I actually was talking to Joe from CloudStack, and I might be looking at whipping up a driver for them. because it's not listed. So if there's anything that any of you are interested in, feel free to shout out.
So the API that these Aeolus modules like expose, those are just a front end for all of the specific APIs for all of those providers that were listed.
Yes.
And any of this stuff functioning is based on the assumption that these guys aren't going to change anything, just like that. But as soon as they do, everything will break.
Well, if you're using a specific cloud implementation and they change, I mean, usually when you're releasing a version of the API, they announce it because they have customers too that are depending on we're not the only ones using their APIs. But they could change, and this technology is 100% geared towards portability, and adaptability and abstraction. So, the focus of our project is to keep up with those changes. So that's kind of, where Delta Cloud is very limited in scope to just these core features that, if there is a change on the cloud provider, we can quickly adapt to that.
I suppose to ask my question from the opposite direction, at what point are we going to have the standards so that like all of these people are providing the same API, and then we can just use?
That's a good question. I mean, I don't know. I mean, that's part of the uncertainty. I mean, you have to ask yourself, if you're Amazon EC2, would you want to provide that function?
Right.
And easily migrate. So, this provides a way to use all these cloud providers use the same API as of today. So,
Right.
I mean, this is
it's great.
very easy. So, any more questions or anything? Okay. So we're a little early, but if anyone does want to talk or anything, I'm more than welcome to stick around. Make sure to pick up stickers over there if you missed it. They're also at the Red Hat table. AeolusProject.org, our mailing list, our IRC channel, very vibrant community from all over. Yes.
Does Red Hat have any other cloud-based products, any proprietary products, or are they all?
Almost, not all, but the vast majority of Red Hat software is open source. All our cloud products are open source as far as I know. One of our biggest cloud products is OpenShift. For example, we have if you go to our website, you can see a proof of concept of running OpenShift on Aeolus. So you can run it against, on any cloud provider. And OpenShift is a bit of a complicated service to set up, obviously. But OpenShift is open source. And initially it wasn't, but then they released the source code, and it was never intended not to be. It was just this is how it worked out. I don't think there's anything close.
Have the link for the
That what?
the POC OpenShift.
Oh, not at hand. Yeah. I know there's templates written for it and everything. So, the presentation, all the commands I demoed, and so on and so forth, is on my blog, mo.morsi.org. If anyone wants to shoot me an email or any feedback or anything, find out my contact information there.
Yes, Mo. You had shown a image creation tool. Is that image creation tool, can it create distributions that are different than the distribution it's running on? So for instance, could it create a Debian distribution image?
Yes.
And running Fedora?
Well, like I said, it uses Oz. So what Oz does is it creates a very bare bone instance using, now Image Factory is what actually delegates the commands to different cloud providers to build images using their tooling. And then it's, a lot of cloud providers, almost all of them, I mean there are some exceptions, but they usually base images off of instances. So it'll spin up an instance, it'll be Debian or Ubuntu or whatever. Oz is available for all those. Oz will be used to bootstrap the local environment and everything it needs to use to run your services and so on and so forth. It does what it can do beforehand. runtime generates the image with, Oz baked in, and then at runtime, if it, it needs to pull in like a config server and get additional configuration using all the native tooling, once again, it does that. So. Okay. Thanks for coming, everyone.